Well, it seems that we had the announcement and that not too many people are still coming in. So let's start. Niels asked me to, well, to basically tell that we are starting and to close at the end. So today we have the presentation. It consists of 3 parts. And if possible, please ask the questions at the end of the part. Only maybe if it is very urgent, because you will not be able to understand. Otherwise, ask your question immediately. But otherwise, please keep them until the end of the part. And it seems that everybody already muted except for Marielle and me. So let's do that, Marielle, and then we can give the floor to our presenter.
Yes, thank you very much, Rob. Good afternoon, everyone. This is the first colloquium after summer holidays. I hope you have had a great time. For today's presentation, I have a variety of audience, so I made my presentation in 3 parts. Part 1 is regarding vibration analysis. Part 2, asset management, and part 3 is about PdM methodology. This is a brief version of my CV. My name is Alieh Alipour. I'm a lecturer in asset management and project leader for PrimaVera project in Den Haag University of Applied Science. I've gained my PhD in TU Delft in pavement engineering, and I have worked as advisor in asset management for Arcadis and as innovator and advisor for TNO. As I said before, today's presentation has 3 parts: vibration analysis, asset management, and a structure of deliverable. First, vibration analysis. As you know, there is a strong will to build a test setup. This test setup will have components such as electric motor, bearings, pump, and gearbox. After we have the test setup, we will install most probably vibration sensor, and we will collect the data. These data can be used by work package 2 and 3 for diagnose phase and prognose phase. So in the following slides, I introduce some terms and definition which will help our data analytic people in future to work easier with this data. The inspiration to make the following slides is based on an interview with our contact person, Amir Branken, in Royal EHC, and it is also based on the content of books from Mobius Institute. So this part has the following structure. First, I will say about principles of vibration, then data acquisition, signal processing, vibration analysis, and fault diagnosis. Let's look at the principles first. As you know, all rotary machines like fans, pumps, motors, turbines, and compressors will vibrate. One way is to listen to the vibration to detect faults, but that's only part of the story. Another option is to install sensors to measure vibration to detect faults. And the process is as following. We collect vibration measurements, we analyze them, and then we can know the condition of our rotating machine. A very simple question. Why does a machine fail? Either there is a problem during manufacturing, or during installation, or during maintenance. What kind of fault can be detectable with vibration analysis? Bearing problems, unbalance, misalignment, looseness, soft foot, electrical fault, eccentric rotors, belt and coupling problem, gear mesh, and broken rotor bars. These are the type of the faults that we can detect them with vibration analysis. Our contact person in Royal EHC has asked us to focus more on the bearings problem. However, there is the possibility to also look at other type of faults that I've mentioned here. The vibration can be measured in 3 directions: up and down, vertically, side to side, horizontally, end to end, axially. The first series of data that I received from Royal EHC, they are actually acceleration and velocity data that are measured in axial, vertical, and radial direction. What is interesting is that we also have the failure analysis that is being done by the manufacturer over the bearing, for example, that they detect some failure with vibration analysis. We also have the failure analysis. So we can compare the two results together to become confident that this detection has been done correctly. There are in total 8 series of data available plus failure analysis of those data. Generally, we have 3 types of sensor. We have the sensor that measure displacement. They named it proximity probes. We have velocimeter and we have accelerometer. And the best location to mount the sensor is usually the bearing location of each component, unless it is not possible, maybe because it is covered or it's not possible. There might be a question that when should we measure displacement, when velocity, or when acceleration? Before saying that, I should also say that it is possible with some mathematical formulation to convert one unit to the other. If we are interested to look at low frequencies, it's better to install displacement sensor. If the frequency range that we want to study or focus is between 2 to 2000 Hertz, velocity is a better measurement. And for high speed machines that the speed is more than 10,000 RPM, or when we want to do bearing analysis or gearbox analysis, using sensor to measure acceleration is a better option. It is recommended. Another term or principle is forcing frequency. The frequency tells us the source of the vibration, and the amplitude tells us about the severity of the vibration. Knowing the forcing frequency, we can immediately relate it to a special fault or a special component, because every component has its own signature, has its own forcing frequency. These forcing frequencies can be calculated based on geometry properties, and there are also some sheets available that they have calculated the forcing frequency of the components. The concept of forcing frequency is essential in fault diagnosis or condition monitoring. Forcing frequency allows us to relate a specific peaks in the spectrum to either particular machine components or particular mechanical faults. Another important principle is order normalization. Up to now, if I was speaking about frequency, it was usually in hertz. But if we use order normalization, we show the frequency in terms of running speed or its multiples. For example, 1 RPM, 3 RPM, etc. The first peak is usually, actually always, the fundamental frequency, which is the shaft turning speed. Harmonics are a series of evenly spaced peaks that are multiples of the fundamental frequency. But what is the benefit of doing order normalization? If we show the frequency and in the x-axis in terms of order, it will help us to calculate forcing frequency easier. Another thing is that if we change the speed, we can compare the spectra, and it is possible to compare a spectra at different speeds. Plus, we can see if the peaks in the spectra are related together or not. Next is data acquisition. If we collect the data, we should be immediately understand the data is not good if the following things happen. If the machine is not running at the current speed or load, if the incorrect sensor is used, or if the sensor is mounted incorrectly, or the sensor is mounted in the wrong position or orientation. This part is actually our main task within Den Haag University of Applied Science, to come with a good suggestion of the best type of sensor, the best location to be installed, and the proper orientation. How can we recognize bad data? If we look at the spectra and we see thermal transient, mechanical shock, sensor overload, loose mounting, and unexpected harmonics, or poor setup, that should be for us an indication that the data is bad. So better to recognize it immediately rather than send this data for the next phases to be used by machine learning or data analytics. Signal processing. I will not explain everything about signal processing. I will just say briefly some important terms in signal processing related to vibration analysis. One thing that we should know for sure is Fmax. Fmax is the highest frequency that can be displayed in the spectrum. If we don't know the Fmax, we may look at a smaller range in the spectrum and probably we will miss some of the faults because maybe the frequency is not visible in this range, in the small range that we are looking. Another important term is LOR, or lines of resolution. It actually indicates how much detail can we see in the spectrum. We should also know the units, whether we want to work in displacement or velocity or acceleration. The more data we collect, we will have greater resolution, but we also need more time to collect these data. And we should also know that there is a balance for resolution. If the resolution is very high, we also need more storage to save the data. Another important term that we use in signal processing with regard to vibration analysis is different sort of filter that we use. We use low pass filter, band pass filter, band stop filter, and high pass filter. Just an example, for example, high pass filter allows that the high frequency pass and the rest of the signal remain. Vibration analysis. This is just a view over the steps that we have in vibration analysis. Most of it I already explained, just I will go through it again. So we validate the data. We normalize the data, as I said, by order normalization. Then we identify forcing frequencies in the spectra. Then we identify harmonics and sidebands. Then there is diagnose, followed by verify, and finally report. Fault diagnosis. As I said, our focus is on bearing failure. And here is this graph shows that 34% of the failure of the failure in bearing happens because of the fatigue, 36% lubrication, 14% contamination, and 16% handling and installation. What are the components of a bearing? It has inner race, outer race, cage, and rolling elements. Each of these components, they have their own forcing frequency, which are named by BPFI, BPFO, FTF, and BSF. There are mathematical formulations that these forcing frequencies can be calculated. One example, this is the spectra, and as you see the harmonics, you can detect BPFI, which means in this bearing, the damage has happened in the inner race. Here we detect BPFO as forcing frequency, which tells us that there is a damage in the outer race of the bearing. In this example, the damage has been happened in the rolling element. So we recognize the BS. And now I want to tell you about enveloping. It's a method to recognize early failure in the bearing. You will hear it often, and I was thinking it's good to add some slides to explain them. As you see in this signal, we have some high frequencies which might be noise, or it might be that they are related to some damages in the bearing. First, we amplify it greatly to see them better. Next phase, or the first step, let's say, is to use a high-pass filter to separate those high frequency from the rest of the signal. As you see, the damage is probably in the outer race, and those high frequencies are related to the damage of the outer race of the bearing. Step 2 is rectifying. We use full wave rectifying. So the negative going energy vibration is folded over and made positive. So everything we have negative in the signal, they become positive. This is rectifying. Having the rectified signal, we apply a low pass filter, and those high frequencies converted to low frequency. And next step is to generate the spectrum, and we analyze either the time waveform or the spectra to see if if we can detect some of the forcing frequencies of inner race, outer race, or other components of bearing. In this graph, you don't see yet the harmonics of the damage in the bearing, but through the time, if we keep doing this, we can, after a month or after 2 months, if there is early damage, we can see some peaks, which we can easily relate them to the damage in the bearing. Are there any questions? This is the end of part 1.
Yes, I had one. I was wondering, where's usually the sensor on the ball bearing mounted?
What was the question? Where?
Where's the sensor mounted on the bearing? So if the bearing.
For this example, for example?
Mm-hmm.
That I don't know.
Okay.
Because these were just the results of the source that I used to have these plots. It didn't have information about where it has been installed. Why is it important for you? What question or? Well,
not. I mean, just in general, because if you have a signal, I was just wondering where it was measured. But no problem. It's not.
It's.
Add some information to that. Is that okay?
Yeah.
The exact position of the sensor depends a lot of the situation you're at. Like this is one of the tests we want to do with the test bench. What is the best position for a sensor to measure? We would know which part of the system we want to measure, but there's different ways to attach the sensor to the outer housing or just on the inner housing, or what is actually there's this balance between what's feasible and what's best. It's really something that we have to find out what type of sensor at what position will give you the information that you need. And that will obviously not be as clean as in this example, but basically we need to go as close to the example as possible.
Okay, that's very clear. Thank you.
Okay.
So if I can also ask a question. So I understand that the example itself, so the data doesn't come from you, but this approach, that is that your approach, or is that an approach that is?
This is not my approach. This is a common approach that is used in vibration analysis to detect damages related to high frequencies. And in future, if we want to use it, I was thinking let's introduce it because it's very common.
Yeah. Yeah. Okay. Thanks.
Yeah. Maybe to add on that, it is a method which is very takes a lot of interaction of experts to interpret the graphs, and that is something which IHE wants to automate. And basically, they taking part in this project to see how much machine learning multi-sensor methods can automate this approach and maybe also even improve it.
What we just showed is their method, that the method they apply to the data from ships' propulsion systems. And there's an analyst looking at those data as soon as they come above certain threshold values. And the analyst has to consult experts and decide what's happening. And it would be really, really nice to be able to make an automated prediction as far as can be. So in the end, and that's like in the very far future, there will be autonomous ships on the ocean. That's what they want to work towards.
Yeah. No. Okay. That's clear. Thanks.
Okay. Now I give 10 seconds pause so you can refresh your mind for the next, because the next topic is completely different from vibration analysis. Okay, this is part 2 about asset management. As we know, asset management, the main benefit or the main goal of having asset management within an organization is to bring a balance between risk, cost, and benefit. In this part, I will talk about the general elements of asset management, and I will try to link it to predictive maintenance and the work packages that we have within PrimaVera. The slides that I have made are based on ISO 55000. It's a famous ISO that has explained all the terms and definition of asset management. A simple question that I want to ask yourself. You don't have to answer it loudly, but what do you think about assets? What is an asset? Asset is an item, thing, or entity that has value for the organization. Who is the asset owner? Asset owner is responsible for the governance system. It's the asset owner who should define and determine which stakeholders are important and which value should the organization take. So basically, the long-term vision is determined by asset owner. Who is asset manager? The asset manager controls the risk that might occur for the vision and therefore thinks and plan for the asset management. Who is service provider? When the plan is made by asset manager, it should be performed by service provider. A simple example, think about your mobile telephone. It's an asset because it has value for you. And who is the asset owner? You are the asset owner because you are the one who decides whom to call with this mobile telephone or which application should you install on your mobile telephone. You are also the asset manager because you plan to charge your mobile telephone every day. But remember, you only plan for it. When it comes that you actually connect your mobile telephone to the charger, you have the role of service provider. You are also the user of this telephone. So basically, you have all the roles within asset management when you use your own telephone, your own mobile telephone. But in big projects, these roles are not the same. They are different. So it's important to know what is their role and what is their responsibility. One example before I go to the terms of asset management, Schiphol Airport. In 2017, they start their maintenance plan with the goal of having a digital twin for their assets. And the number of assets that they have is 80,000. Asset management has different layers. It's like an onion. In the innermost layer, we look at the components. One layer above is industrial, and then the entire building. Then it comes to asset portfolio, then asset management system. In the higher level, asset management, and in the highest level is managing the organization. The first element of asset management system, let's say you either have asset management in your company or in your organization, or you are interested to have it. If you want to have it, you need to think about the elements of asset management and to create them. The context of the organization is the first element. It is the environment where your organization is located. It can be external or internal. External context is like financial context or economical context. Internal context is, for example, the internal culture of the organization. Analyzing and managing the risk and stakeholders is actually context analysis. Then it comes to stakeholders. A stakeholder is someone who has an interest in the functioning of the organization. Then there is policy. Policy or blade for asset management is a short statement outlining the principles. It is being determined by the leadership. Leadership is the managerial part, and they should be familiar with the terms and definition of asset management. They should use it in their communication if they want to bring it into their organization, and they should be supportive of the strategies and activities related to asset management. Then there is a scope. A scope is actually the boundaries of asset management system. Based on context, policy, a scope, the leadership defined the asset management objectives. These objectives should be SMART, which is a specific, measurable, achievable, realistic, and time-bound. When we are confident or when we define the asset management objectives, the next process is asset management planning. Actually, here we should plan to achieve the asset management objectives. We should also develop the risk matrix in this process. Then there is support process. This is another important element of asset management system. In support process, we should think about our resources, the competence of our people, awareness, communication, information management, documentation, and control. For example, if we want to have asset management in our organization, people should be aware of it, or we should have enough competence in our people. For example, we should have people who know data analytics, or people who are familiar with data storage or information management. Okay. So the objectives are clear, the plan is clear, the support is clear. The next process is operation process. Here, for example, operational planning and control, management of change, and outsourcing. If we want to go from a traditional system in our organization toward an organization that has an asset management system, there is a change. And management of this change happen actually in the operation process. Or some of the tasks and responsibilities may be outsourced to service provider. That will be done in this process. After all the activities that I mentioned, it's time to evaluate. We should monitor the activities by doing internal audit, for example. We should evaluate the performance of assets, asset management, and asset management system. The lessons that we learned from evaluation process, we should use it in improvement process. We can improve the plan or we can improve the operation process. If we see some accident or some incident that occurred in the past, we should do corrective action. If we see some incident, some potential of incidents that might happen in future, we should do preventive actions. And in general, we should continuously improve our asset management system. As you see, it's not a linear process, it's a loop. You do activities, you evaluate, and you improve, and you keep doing until you get the results that you are expecting from asset management system. Now, predictive maintenance in asset management. These are the work packages that we have within PrimaVera. And they're not linear. There is a loop, as you see. For example, there is an interaction between work package 6 with all the work packages. So I want you to think about these work packages, and try to link it to the general terms and the general slide of asset management. And we will go through in the following slides. We will try to discuss some similarities and differences. For example, leadership. Is there anyone interested to link some of the work packages in PrimaVera with leadership? For this part, I need your interaction. So please be open and share your opinion with us.
Yeah, I think leadership is a very broad topic. So what do you mean here? Can you give a little bit more details?
I will say myself an example. For example, the management, the part in an organization, they should know the value and limitation of using predictive maintenance. Whether it will have, for example, in the short term, it will increase the cost, but in the long term, it will bring more confidence to the company, and it will maybe in the short term they have to invest, but in the long term it will bring a lot of benefit to the organization. And the managers should be very clear for them how predictive maintenance will influence the entire organization.
Mm-hmm. And how do you think we as a project could then contribute to this awareness?
We have some partners from industry, and they are most probably interested to bring predictive maintenance. Some of them maybe they are themselves, they have managerial roles. Some of them maybe they have technical roles. Mm-hmm. So if they can, if they have managerial roles, they will be informed directly, for example, by this colloquium or by interaction with us. If they are technical part, they can somehow make a summary or inform the higher management that yes, this is in the long term, you need to invest on this part and you will get in future these benefits.
Yeah, mm-hmm. No, of course, and there are in the work package 5, this is about human factors and human and organizational factors. So people like Jan Braaksma and Leo van Dongen, they are looking at this. But I think it's a quite big topic that requires also a different, let's say, scientific approach. And so if you are interested, I think they are the ones to talk to, and it's their expertise.
Yeah. Actually, I was hoping that our people in industry can participate more and say their opinion, how they think that predictive maintenance and work packages of PrimaVera will influence their organization, just to have an initial idea.
Well, maybe I can give a brief comment. Well, my colleague is not here. Can you hear me?
Yes.
This is Stefan Rijs from Wildeboord de Dommel. Well, we're involved in PrimaVera because we want to investigate how predictive maintenance can help us in the overall asset management. So we hope it can help us in improving the asset management by having a better optimum. So I think in this case, well, we are both in a management position, and then if we see that there's potential that we can really apply, we will do it. So I think that's possibly where you say, and we also have defined a risk matrix already. That's already there. So parts of the whole scheme here is already there, but we do not really have predictive maintenance yet. So in fact we are partner in this project to see how and where we can apply this to improve the overall picture. So that's in our case, and I'm more the innovation person, and my colleague Twan is responsible for the maintenance. So together we hope as managers to be able to also apply this in our organization to improve the whole maintenance and asset management. So that's an example, maybe. So
thank you.
Just,
and I have a question from you. I personally think that having performing predictive maintenance will help us to have a more realistic risk matrix. Do you agree, or do you think the same, or no?
I hope so.
Yeah.
Of course. Well, you just gave a sketch of the whole procedure. You have to have good data. You have to have a proper way to analyze from the data. Is there a failure to come? And for some devices that's relatively straightforward, but for others it's not. So we do not yet know for which type of applications or devices we can apply this. So we're just at the start.
Yeah. Thank you very much.
We're not sure that. So we hope we will be able to improve it.
Yes, I hope so too.
Yes.
Is there anyone?
Yeah.
So what Stefan says is, I think what many companies also think, they want to see, they participate in PrimaVera because they believe in it, and then they want to see what works, what doesn't work, where can they benefit from.
Yes.
Yes. I will give another. Stefan talked about the risk matrix for support process. For example, within an organization, we see if we have enough people who are able to do data analytics or machine learning. Should we have a new department, and what should be the communication between consultant and data analytic department? These are all being influenced in the support process. In operation, for example, maybe a company decides not to have a department of that they do predictive maintenance. Instead, they outsource it to a service provider. There is maybe a small company who are expert in data analytics. So the organization, instead of having a big change, they just outsource that part to a smaller company. In the evaluation, for example, we can evaluate predictive maintenance with preventive maintenance and corrective maintenance and see, does it really influence the asset management system or not? And improvement, of course, if we apply predictive maintenance, we learn some lesson which we can improve other processes respectively. Are there any questions? Okay, there is again 10 seconds or 20 seconds pause to reset your brain for the next part. Okay, this is part 3. It's about how we want to give a structure to our deliverable within PrimaVera. The inspiration of the following slides comes from a PdM document. It's a document that was shared by Dr. Johan Linsen and Dr. Wouter Thiel from Saxion University. PdM is a very famous and most widely used analytics methodology. It is the afkorting of cross-industry standard process for data mining. However, it has some limitation. It does not cover the engineering context, and it is not about production of data. To overcome this limitation, there is another document which is extension to PdM. It is data mining methodology for engineering. In the following slides, I will explain about the structure of PdM and DMME, and then I will link it to the deliverable of PrimaVera. The first chapter or the first part is business understanding. In this part, we should define the business goals and data mining goals. Next chapter is technical understanding. For example, this is related to the test setup, if we want to build it to generate data. In this chapter, we should explain about analyzation of the application of the test setup process and related parameters. We should explain about technical goals of building a test setup and definition of target variables. Then there is technical realization. This chapter is related to building the test setup. So it is about develop a technical test setup, conduct this experiment plan, and document all steps. Next chapter is data understanding. Data understanding has the following activities: collecting initial data, describe them, explore them, and verify the data quality. After that, there is data preparation. These, for example, the following activities: selecting the data, cleaning the data, construct the data, integrate, and format them. Okay, having the data, it's time to use model. First, select modeling techniques, build the model, and assess the model. Then there is time for evaluation. We should evaluate the results, review processes, and determine next step. Now that we have evaluated and let's say evaluation is done, there is enough confidence for technical implementation, which means the following activities: streaming data over a long period, and develop or select a software infrastructure to collect, pre-process, and analyze the sensor data over a long period. And finally, there is deployment, which has the following activities: plan deployment, plan monitoring and maintenance of what we have built and what we have made, produce final report, and review project. This was the structure of PdM and DMME. We think it's a good structure for communication in this complex project. Our main task is to look at the data, sensor position, and type of sensor in Royal EHC, and then come with a suggestion for type of sensor, sensor position for the test setup. So we get inspiration from some of the chapters, not all of them, but some of the chapters that are in this document, in this structure. We will use that as an inspiration. Are there any questions? Thank you very much for your attention.
I have one question maybe about this final part. So can you be a bit more concrete? So you are working on the sensors, and you explained that you are, let's say, going to apply this method. That's what you explained in part 1, that you're going to apply this method that the IHC is already using, but that you want to automate it, basically.
That is one of the activity. The other activity is to build a test setup and then suggest the location and type of sensor for this test setup.
But does that mean that that you will go through this complete loop, or how do you see that?
No. We will use some of the chapters. It's not if we build the test setup, the we will the business understanding, technical realization, and part of data understanding. And the rest we should see, but it's not we will not use the entire loop because some of the tasks are actually for the other work packages.
Yeah, exactly. Okay, yeah, that would be my follow-up question. So that means that you would say that together in PrimaVera we should complete that loop.
I don't say we should. I say this is a good suggestion.
Okay. Okay. Thanks.
Yeah, thank
any
you.
other questions?
Yeah, I also have a question, also on the loop, namely, how you have that loop. Also in PrimaVera, we have also the work packages that are also in a loop. They're a bit different. I'm not saying that the PrimaVera way is the one and only official way, but can you compare and yeah.
There are some arrows that connect these chapters to each other. I didn't put those arrows. For example, when we evaluate, there are some link between evaluate. We can come back to data understanding, or we can come back to data preparation. So there are some inner links that I didn't put them. They are not in a sequence. It is, in a way, I think there are some similarities between going forward and backward that we have in PrimaVera. There are some similarities with this loop that we have in this methodology.
Because what I don't see in your loop is, for instance, prognostics or or predictions at all. What you really do with what you use the data for.
I think it comes in the modeling. I think so. Yes.
Yeah, my impression is that this scheme is much more general and abstract than the PrimaVera scheme. So PrimaVera scheme is really oriented at maintenance, while this is a more general scheme for data mining. At least that's how I interpret it. And so this is a more general scheme on data mining, and one of the applications of data mining can be predictive maintenance, but it's a much more specific task within asset management, and I would say data mining is maybe just a part of asset management.
Okay, no, that clarifies. Then this could be a loop inside work package 2 or the second phase in the PrimaVera cycle. I think that makes a lot of sense, indeed.
Yes, and in fact, in relatively abstract terms, because this business understanding can relate to several business goals and several data signals or assets or whatever. So it's a very general scheme in my understanding. Is that right?
Yes.
Stephen, it is a very general scheme. It's a very general method, and we are actually using it in work package 1. As it will describe what is the problem, where should we go and measure, that's the technical understanding. We have to make the test bank, the technical realization. What do we get out of that? That's the data understanding. So it takes us, we are actually discussing this with Wouter and Tito. They're both not here, I believe, to make this go and work on the maritime sector.
Okay.
Yeah. And it's actually Wouter who is applying this at Saxion to most of his projects. So we want to speak one language, and we want to really use this in generating deliverable 1, as I recall the method of sensor acquisition.
Yeah, no, that makes sense. And do you also plan to make a kind of flow chart or a decision chart that helps people being guided through the process, or is that not in your?
The thing is, we're now actually at the technical. We had the goal, of course, with the task and the deliverable, but you have to look at what is actually there. And what can you make from that that's still very useful? And we're in the goal of developing that with Wouter Theo and Tilo Tinga.
Okay.
Yeah.
Yeah. No, sounds like a good team of people. So
Yeah.
Well, again, are there any other questions? If not, then I hope to see you again in 2 weeks, although we have some discussion about the next presentation. And for now, let's thank Alieh.
Thank you.
Right.
Thank you.
And then see you hopefully in 2 weeks from now.
See you. Goodbye.
Thank you.
Bye-bye.
Bye-bye.
Bye.
Bye.
Bye.